All right, morning. I'm Chris Brooks with Seepex. We're a progressive cavity pump manufacturer. I'm out of, I cover the southeastern U.S. I'm out of the Atlanta area. So, I don't know, has anybody used progressive cavity pumps before? Are you familiar with?
Yeah, we have them on our centrifuges.
Okay, all right. Any issues, complaints, everything seem to work okay? So,
What was that machine? That's got to be 10 years old.
Okay, good deal.
That's probably about the only part we've had
That we haven't
we
changed.
haven't really.
Yeah.
messed with.
Okay, so Seepex, that's really all we do. We do macerators that we typically put before our pump to reduce solids if it's a high solids application. And then we manufacture progressive cavity pumps. We got some pretty innovative designs. Your pumps out here are just the standard, the N series we call it, which is normal or standard product. So I'm just going to kind of go through some basics of PC pumps to make sure everybody understands. You know, there's a few things you can't do with them. You can't run them dry. And I'll try to show why that's an issue. And then we'll kind of go through your individual pumps, what to look for, you know, maintenance type, and then we'll go out and take a look at the pump. So if anybody's got any questions as we go, please stop me. You know, I've been with Seepex for 3 years, been selling the product for over 20 years. I was with a distributor in the Georgia area for 20 years, so it's a good product. It's used a lot for solids handling, chemical metering. There's a lot of different applications you can do. We do cake, you know, pumping cake into a dryer or like a roll-off. So we can do some very high solids up to about 45%. Just kind of the typical, you guys all signed in. If somebody needs to get up, just let me know and we'll stop and hold up until you guys get back. So again, we're just going to kind of go over some of the pump basics, the safety items to look for on the pumps, and then just talk about your individual pumps. Again, this is just kind of a overview of what we're going to be looking at. Startup plan, we started the pumps, we checked rotation. One thing I would advise you guys of, because we use a gear reducer, sometimes they may be a single or a double reduction. So if you pull the motor off for some kind of service and you hook it back up, you need to check rotation, and I always recommend doing that at the pump shaft. You can't always trust that the motor rotation is going to be correct, because if we've got a double reduction, you know, it may change the rotation. So Seepex is a positive displacement pump. So basically what that means is as the pump operates, it rotates. We form a cavity. That cavity is a known volume. As the pump rotates, we displace that cavity. So we pretty much know per revolution how much volume we're going to get. So typically what you'll see out in the field is either a PD type pump, positive displacement, or centrifugal pump. So we are, you know, pretty much any positive displacement pump you see has got that same action. There's some kind of void or cavity being created as the pump action goes through. It's displacing that cavity. So we kind of fall under the, there's a lot of different positive displacement pumps. I saw you guys had some Penn Valley, which is also a positive displacement. It's more of a diaphragm style pump. So it will kind of fall under the reciprocating. We're actually a rotary single member, so we've got one rotating unit in the pump, one rotor in the pump. So I'll go into some of that shortly here. So on the positive displacement pump, basically you know, when we rotate that pump at 60 hertz, we're going to give you the same volume until we start to wear out the stator and rotor on the pump. So as that starts to wear, you can overcome that flow, you know, decrease in flow by speeding the pump up. So you can overcome that wear by speeding the pump up. So typically you see positive displacement pumps used for shear sensitive products like polymer, metering where you need accurate flow rate. It's low pulsation. We can handle product with solids, very viscous product. So in your case, this is basically going to be like a water-like material, but it's got solids. So if you compare it to a centrifugal pump, the biggest thing is if you started to close the discharge valve on a progressive cavity pump, you're still going to get the same volume, but the pressure is going to increase. Whereas on a centrifugal pump, when you close the discharge valve, you start decreasing the flow rate the pump can do. So again, compared to a centrifugal pump, we can handle a lot higher solids. We can handle more viscous products. It gives you a more accurate flow rate. I mean, all these pumps, no matter how small or how large or a metering pump, we can give you a precise volume of liquid. So. Again, that kind of just covers that as we change the speed, we change the flow rate. So typically on these applications, we'll see a range or 2 different points they try to hit. In your case, it was 100 to 200 gallons per minute. So basically, to get from 100 to 200, you double the speed of the pump. These pumps are low MPSH, so we, in your case, we can actually pump that tank down very low, that basin very low. There's only one shaft seal. A lot of times people will use like a rotary lobe pump, for example. They have multiple shafts, so each shaft has to have a way to seal it. The pumps, a lot of times we can mount these pumps vertically. We can change the rotation and change the port where the suction and discharge comes in. So if we were pulling a really high suction lift, we can run the pump in reverse rotation and eliminate the mechanical seal from being in the suction casing. So really the rotor and stator, when we go out to the pump, I'll kind of show you, but it's really that is the pumping element. That's what actually does the work. So you can see here on the green, that's that rotor, which in this case is made out of a metal that we put a chromium plating on the surface of it to make it extremely hard. And that's rotating on the inside of a rubber or elastomeric stator. So as you join those two pieces together, it's kind of like taking a nut and a bolt, and then you stretch out one of the two. So either you stretch out the threads on the nut or the bolt. When you do that, that's how the cavity's formed. It's kind of a weird analogy, but that's really what's happening. So when you piece those two together, that cavity forms. The cavity looks like this. If you were to take the void that it forms and fill it up with wax and then pull it apart, it would actually look like this shape. So where one cavity stops, the next one starts. That's why we get very little pulsation out of the pump. I always tell people it's kind of like deflating a football and twisting it. That's what the inside of the cavity looks like. So a good way to think of it is as this cavity forms, if you could put something in there, if you could put a marble in that cavity doesn't change for the full length. So you could actually pump that marble through without making any contacts. So again, the rotor's made out of metal. We do a chromium process to actually make this. It goes off the Rockwell C hardness scale. We do that to handle abrasive products. It's a single helix shape. The inside of the stator is actually a double helix. That's that thread, nut, and bolt that I was referring to. Your stator material is actually a Buna material. And then when we put this stator and rotor together and mount it between the suction and discharge casings, there's no gaskets. That stator actually has rubber that extends past this metal tube, and that's what forms the gasket. So rotors, basically we do everything from a single stage up to an 8-stage pump. So essentially, if you think about this rotor being inside that stator, each of these humps is making contact with the rubber portion of the stator. So the more of those contact points you have, the higher pressure you can build. Fluid as you're discharging is trying to push on the end of this rotor, and so it will eventually start to slip past each of these fits. So the more of those fits you have, the higher pressure you can build. So a single stage pump, we can do about 90 PSI. An 8-stage, we can do 748 PSI. So just by extending the number of contact points, and obviously it makes the length of the pump longer, but that's how we're able to develop more pressure. So we can go, over 2,000 gallons a minute with these pumps. We can handle viscosities over, I'm going to look at an application tomorrow that's 2 million centipoise. I mean, it looks like, grout. It's a really viscous product. So you can actually put it in it's like Play-Doh. You can put it in your hand and it doesn't look like a liquid. So we can handle large solids over 3 inches with some of the bigger pumps, and then we go up over 45% solids for like cake handling. So. So, I always recommend you guys got the manual here, so, look through that. It's all the typical safety you want to watch out for. We do put guards over the shaft that's exposed that goes from the drive end into the pumping element. So you want to make sure those guards are in place. Other than that, there's really nothing external to the pump to watch for except like the motor fan. One thing I will caution you guys on, because this pump's positive displacement, if you close the valve on the discharge side, it can build a lot of pressure. So, it's, I've seen some of these pumps on a real viscous product where it's hard to get the product to flow back through the pump, break 3/4 inch bolts on the tank. It built so much pressure in the tank. So, on water, what happens, or a thin liquid, it'll start to slip from the discharge back to the suction, and you'll start to lose performance, but it can build tremendous pressure. There's a section in the manual if you ever have issues where you can't get the pump to start pumping or you lose performance. It's kind of a checklist. Troubleshooting guide is pretty simple to read. It's pretty much spells out any issue you'd run into and kind of a remedy for those. And then I'm going to pull up the data sheets just to show you guys, and we'll go back to that. All right, so you've got two pumps out there. I don't really know why looks like we generated two different sets of data sheets. Typically when we have two identical pumps, we just put them on the same, but I don't know why they ended up doing that. So these pumps are BN. The B stands for a block design, which we close couple these, so there's no external coupling. Everything is close coupled together between the gearbox, motor, and the pump. The size 70, that tells us the flow rate. The 6 is a single stage, 6-bar pressure pump, and it's the long geometry. And then this string of codes is actually the materials that we built the pump with. So the data we originally got is waste activated sludge, up to 2.5%. Does that sound correct for you guys? So then, this first section, we kind of give you the application data. Then we show you what the pump was sized for. So again, it was 100 to 200 gallons per minute, 30 PSI. Again, at 110 RPMs for 100, almost double that to get the 200. Then below that, we actually give the materials of each of the components, how it was built, the size of the flanges, just some specifics of the build code of the pump. This pump has a single mechanical seal. It doesn't have any kind of flush or anything, so it's a dead-ended seal. It's using the process fluid in the pump to lubricate the seal faces. And then we have a geared motor. It's actually a Nord with a standard NEMA. I think that's going to be a 7.5 horsepower, not 10 horsepower motor. So this is kind of an important section on the data sheet, and this is in the manual. So this will show you based on the speed we need to get the, like the 110 would give you the 100 gallons a minute. That would be somewhere around 29 hertz. So if you ever wanted to go out and do a check on this pump, that'd give you a good indicator of what kind of flows you would get based on the frequency you're running. Past that, it's just kind of a little bit of info on the motor, some of the testing that was done initially. This is the other pump. Again, they're identical. I didn't see any differences, so I don't know why they just didn't put it all on one data sheet, unless maybe they added the second pump later or something. This is the dimensional drawing of your specific pump. You can see that this suction flange we can rotate 90-degree increments. Let me rotate this. You can see it. You can see out there when we go out the pump, you added these lifting lugs. That's not a standard feature. We've noticed that's kind of interfered with our fan cover a little bit. So if you pull that fan cover out, we got to come up with some way to squeeze that back in there. You'll see when we go out there, this is pretty much the layout of the pumps you got. That's probably why they did two different data sheets. If you notice, is that right? So one's got the suction facing, so one's got the suction facing one way and one has it facing the other. So This is the pump curve. Again, these pumps are a little bit different than, I don't know if you guys ever read a centrifugal pump curve or not, but it's, let me rotate it. But if you look this up or somebody asks for this information, you can see this 70-6L is the actual pump size. And not to get into too many details, but basically for these pumps, we look at the discharge pressure that we're going to be operating at, and then you look at the flow over here on the left-hand side. So if you needed 100 gallons a minute, this second curve would be the 30 psi. You can see that's where we came up with that 110 RPMs to get that flow at that pressure. So they're pretty easy to read. They look confusing, but they're pretty simple to read. So, get this upside down now. So this is the internals of the pump. Again, this is the rotor. The hatch drawing you see here is the stationary stator. That's a good way to remember it. The rotor starts ROT, that's rotating. The stator's STA, stationary. Because of the shape of this rotor, when it turns, we actually get a eccentric movement right here. It actually travels up and down. So we're trying to run concentric back here with the gearbox, so we have to take up that motion. So we actually add these joints. It's kind of like a CV joint on a front wheel drive car. So it just takes up that motion of the rotor. These joints are rebuildable. They're have some bushings in there that are replaceable. They're hardened. We seal it with grease and then put a rubber cover and some Bandit Junior clamps on it to protect it from the product. So. And then this is just the parts list. So let me go back here. And you'll see this when we go out to the pump. But just to kind of give you an idea, this is what it looks like. The only difference, this is actually a geared motor, we call it. You have an adapter here, so you can go to a standard C-face NEMA motor. But we have a motor, we have a gear reducer. Then we call this section here our adapter. This is where the mechanical seal is located. We do cover this area because there's a rotating shaft with a guard. If you go out and look at the pump and just do periodic checks, you want to make sure there's no leakage from this seal. You know, if there is, if it gets excessive, you know, you do want to change that mechanical seal. This is our suction casing. The standard configurations in this 12 o'clock position. You'll see when we go out to the pumps, you've got one at 3 o'clock and one at 9 o'clock. So this is the pumping element. This is our stator tube, the external portion of it, and this is the discharge. So they're pretty simple, not a lot of components to them. So inside the pump, this is what we've got. Again, they got the metal rotor. We have the two universal joints taking up that eccentric, and then we have what we call a plug-in shaft, which is where the mechanical seal rides. This actually plugs directly into the gearbox shaft, and then you'll see, I'll show you out there, we have a flinger that actually keeps this drive pin from dropping out if it was to stop in the 12 or 6 o'clock position. We do have something that's pretty neat I'll show you out there. So on the pump you'll see a QR code. You can take your, if you got a smartphone, you can take it, do a picture of the QR code. It'll take you to our website. It'll ask you to put in the pump model. You put in that BN70-6L, and when you put that in, it'll ask you for documentation. You can pull up the manual, the drawings, the parts list, everything on the pump on your phone. So it's pretty neat. The gearbox, it does have a Nord gear reducer on it. I've got some lubrication interval information. Typically these ship with like a VG 220 oil. I know a lot of guys use just the standard ISO 220 oil for the lubricant on these. The motor does have some grease connections. I'll get the information for those in the manual as well. So maintenance schedule, this is kind of hard to read, but I've got some hard copies I can show you guys. But, you know, typically it's, you know, I think 10,000 hours is what they show on the, let me see what we show on this particular gear reducer. So it says to check the level monthly. There's actually on the gear reducer, there's a high and low plug. You pull the top plug, make sure you have level. Change the gear reducer oil every 3 years. So, and then the joints. I mean, typically the only time you replace the lubricant in the joints is when you do a rebuild or replace the rotor on the pump. So. You know, we do recommend if you have a gearbox that's been running for a long period of time, you know, a lot of guys will do an analysis of the oil to make sure they're not getting any kind of entrance of water with high humidity areas like this. Sometimes you get some buildup of liquid in there, so it's a good idea if you could get it checked. If not, you just may have to come up with a, you know, an interval to change it that works for you guys. So we did this installation checklist and startup list. You guys will have access to a copy of those, but we just do a walk around, look at the pump, we check rotation, you know, check the valve alignment, make sure everything's ready. We check rotation, and we ran the pumps for probably 5 minutes apiece just to make sure we were getting positive flow. Changed the frequency to 10, 30, and 60 hertz. Everything seemed to work fine on them. So. Shut down, I don't know how long these are going to be shut down before you actually do a startup, you know.
Well, probably a month after.
Yeah.
Really get the plant started up.
Yeah, so typically, you know, as we say in storage, you know, you want to rotate that shaft periodically.
When it gets, you probably waste, what are you gonna waste every day, or a little bit every day, or once a week, something like that?
To start off, there probably won't be much wasting because the plant will be underloaded.
Mm-hmm.
But
How slow
on
can
this
you run
process, I mean,
We were down to 10 hertz today. That's not a problem to go down that
You
one.
were getting floated.
Yeah.
this kind of process you probably want to waste every day, whether it's, you know, it's
Just
1,000
a little,
gallons
yeah.
or whatever. But we're not going to be there right away.
Yeah.
Yeah, just you don't want the pump to sit here for, you know, a couple of months without rotating the shaft. The rotor's heavy on this pump and it's sitting on rubber. It's kind of like getting a flat spot on your tire. If you've got an old car that sits in the garage for a long time, so you definitely want to rotate that shaft to prevent a flat spot. So, and it happens. I kind of hear it on one of the pumps out there. You can kind of hear a thumping, and it'll typically quieten down when you get, you know, some solids in there. But you can tell it gets a little deformed after it sits for a while. So, doesn't hurt anything, but you can usually hear it. So, all right. So, any questions on that? We'll go out and take a look at the pumps. You guys ask questions. They're pretty straightforward, but you got my info. We're repped here in Florida by MTS Environmental, and then we also have an aftermarket partner, Hudson Pump, that can do repair and aftermarket
We deal
service.
with Hudson Pump.
Okay, so both those guys. So usually on the you know, on the new bid spec stuff, MTS handles all that, and then aftermarket would go through Hudson. So. Okay, you can see this kind of looks like the picture we showed. I'll just start from this end and work our way forward. So we've got standard NEMA motor, 10 horse motor. This is the C-face adapter that adapts the gear reducer to the motor. You can see we've got two plugs, this being the drain plug. This is our normal level for the pump. So you should be able to remove this plug. You see I did it yesterday. You can see some leakage, but back the plug out. That should be your fill level. This top part is actually where you would fill the oil. Basically, you would fill it till you start to see oil come out in this area. This acts as a vent, so you want to make sure this hole in it's not plugged. Usually when these ship, they ship with a piece of rubber O-ring. You pull that out, it engages the spring. This is what we call the adapter, which adapts the pump end to the gear reducer. You can see here, this is our splash ring or flinger. Underneath here is the drive pin. Again, we have the plug-in shaft. The shaft from the gear reducer plugs into our pump shaft. Both are cross drilled. We put a pin in there, we cover it with that flinger, and that's what drives the pump. This section you see here is our mechanical seal casing. So the stationary seat is back in the back portion of this. Then the spring and the rotary is mounted to the shaft. So if you had a seal leak, you would see it coming out here. So that's a good check to do. Again, we put these guards in place to protect you from the rotary shaft. This is our pump suction. These are 2 clean out ports or inspection ports. When you rotate the casing, again, we can rotate it at 90-degree increments. When you do this on this, you know, with the access ports, you really can only access the top side. But still, when you go in there, you'd actually see those 2 joints we talked about. So if you were to get ragging or something wrapped around the shaft, you could access it there and clean it out. So then past the suction casing, this is our stator. We actually compress it between the suction and discharge housing with these tie rods. When you put a new one on there, it's just a tightening. You're tightening rubber gasketing basically, so there's really no torque spec on that. If you had to replace this stator, which is the wear component, you would probably have to remove from here to here of this piping to give you enough room to remove that off the end of the rotor. So one of the designs we have now, we actually have a split stator. So instead of having a metal tube, we actually have 4 clamping devices here. You remove those 4 clamping devices, then you have access to 2 of the rubber halves, and you can remove those without removing any piping. So that's just this pump could be retrofitted down the road for whatever reason, probably the specification they wanted this design. So when you run the pump, you see here that we've got the tag on the pump that shows the rotation. You always want to check the shaft here to make sure that's the correct rotation. You remember what I said about the motor may be turning one direction, the gearbox are turning another based on the reduction. So the code I talked about is here. So if you pull your phone, and you guys can do this.
I got a quick question.
Yes, sir.
Can you pull flow through this pump without the pump running?
No.
Not at all.
Yeah, because you have a compression. So between that rotor and stator where those fits are, it's about a 20 thousandths compression. So, you know, this is rated for 90 pounds per stage. So in theory, you would have to put 90 pounds here to get anything through. Yeah.
So in other words, the centrifuge won't be able to pump through the pump.
Yeah, you'd have to rotate. So we do food grade pumps a lot of times, and they want to be able to do a clean in place or CIP. And when we do that, we actually come in here and put a bypass, and we'll run the pump a few revolutions to clean it, and then you have to bypass for the remainder of the cleaning. So yeah, if you're going to go pump through, you'd have to pump through to get liquid through it.
If they're gonna sit dormant for a while, could we use that to hook up some water to it to run it?
Yeah, you could.
Because you don't want to run it dry.
No, you don't. Yeah.
You want to make sure your valves are open too.
Yeah. So it'd be hard to get enough in there just through these plugs. Is that what you mean through this?
I'm just asking.
Yeah, it'd be hard to get enough in there. This is a pretty high flow pump, but you know, you'd probably be better off to try to.
Is there still water in that tank?
Yeah.
There is.
Yeah.
Yeah, we were about a foot above the suction line this morning.
So this is what pulls up if you do the scan code on there. And up here in the upper left, you can hit documents. It'll ask you for pump type. If you look on here, it's a BN70-6L. You have to put that in. You hit submit. And there's the O&M manual, the sectional drawing or parts drawing, so you can access all that while you're standing here. So you'll see on here, we call our serial number a commission number. Anytime you need parts, they're going to need that commission number. That's like tells us everything how the pump was built. So yeah, that's a good point that you had. So and really that's how this pump works is because you can't. Liquid won't go through it like that. I mean, that's the advantage it has. So literally right now it's acting as a valve. You know, if you had this tank full and the pump sitting here, nothing's going to be on the discharge side unless the stator's worn out. So that's usually a good indicator that you've got stator issues if you're getting flow through the pump. So all right, any questions on that? Again, they got lubrication points on the motor bearings. the oil level, the pump has no bearings in it. All the bearings for the pump are in the gearbox. So this pump, the design you have here with the close coupled, there's no bearings or anything in the pump. So.
How do you maintain them joints? Or you don't?
There's really nothing to do to them. I mean, we, you know, if something went through the pump and cut them, they are rubber. So if something cut them and exposed, you know, flushed all the grease out, you'd have to rebuild them. But as far as just a standard maintenance, there's really nothing to do except rebuild them when they've got enough wear on them. So something else you'll see, we're pumping clean water with this pump right now. You don't think about it, but when you go to solids, you end up with fats and polymer and all kind of stuff that helps lubricate. So the pump will be quieter than it is now. When we've got just clean water in there, it's kind of like your windshield wipers with the mist and rain. You know, you start hearing a little squeaking between that rotor and stator. So. All right. Do we want to run them or?
Sure.
Operate one of them.
Yeah, let's do it.
Let me.
Where are you pumping it to?
Well,
Right now?
Yeah.
it's a floor drain.
Pump to the gravity line. So, and then go over the drain.
Yeah, right now. Yeah, there'll be availability there. 7131. 30 hertz.
Okay. Yeah, so the biggest thing you don't want to do, you always want to make sure your valves are open. You don't want to run the pump dry and you don't want to deadhead it. So if you run it dry, that compression fit between the rotor and stator will build up friction real quick and you'll heat it up. The rubber will swell and you'll actually destroy the stator portion of it. And then if you were to close a discharge or have a plug, the pump will build tremendous pressure. So.
The reason I asked the question is, so it's gonna go to a machine,
Okay.
and that machine has a pump on it. So
Okay.
it'd be a pump feeding a pump.
Okay.
So that's where you kinda gotta be careful
Yeah.
with the pressures.
Yeah, you got to make sure that pump's on when this one's on.
Right.
Yeah.
So,
So you can hear that noise. I mean, part of it's the VFD, but you can hear a little squeaking. That's that rubber with just clean water on it. So. Yeah, we're turning pretty slow right now too. So.
Yeah, that's at past 30
Yeah.
hertz right now.
So in theory, that should be your 100 gallon a minute flow rate. So.
So half of that, you're running 50.
Yeah. Yeah. So literally, if you went to 15 hertz, it's linear. So.
And you said you got all the way down to 10?
Yeah.
You can get down to 10 hertz.
Typically, I tell people just as a rule of thumb to try to stay above single-digit hertz.
Yeah.
Although these motors are probably a 20 to 1 turn down, so that's 3 hertz. But you know, typically you can start seeing a little pulsating flow because that cavity is so large, you're displacing it. You'll start seeing a little bit of pulsating flow if you get real low on frequency. So.
All right.
Good deal. Any questions from anybody?
How long will one of those stators last?
So like on this application, I mean, this is,
It's gonna be a long time.
yeah, it'll last a long time. I mean, you know, it's a good lubricant. It's, you know, if it was, yeah, as long as you don't run it dry. I mean, primary sludge sometimes got a lot more grit in it, so it doesn't last as long, but typically lasts, I mean, you may get 5 years normal life if you're running a lot, so.
We shouldn't get too much grit by now.
Yeah. Yeah, and so they, you know, I've seen them last on cake where it's, you know, high pressure cake service. I've seen them last 5 years. So.
Well, our Centrisis ones, we've never serviced, taken them out.
Yeah.
And they run quite a bit.
Yeah, we've got pumps on polymer that have lasted 20 years. You know, they've never changed anything.
That's
So.
a good lubricant.
Yeah. So yeah, running on dry is really the killer on these. We also have a device. It's kind of strange they didn't do this, but we put a temperature sensor here, and we've got like a controller, so we'll set it at 50 degrees C or about 120 degrees. If it runs dry, it'll build up temperature quick, so we actually shut the motor down. But that's an option too. If down the road you guys want
Probably
to.
costs more money.
That's what it was. Yeah, they were pretty cheap on this job. So, I think that's why they didn't go with the split stator too. You know. So, yeah. But for you guys down the road, if you wanted to look at changing it to the smart stator, you could do that. There's a kit available and it doesn't change.
All set, ready to go, ready to you can leave.
Yeah. So the only thing that happens is we made it to where it would fit in this same footprint. So it shortens the length of the rotor and stator slightly, so it's about a 7% decrease in flow. So you'd have to speed the pump up 7% higher to get the same flow.
It's a piece you add in there.
Yeah, so you actually remove this rotor and stator, and then where that joint is at the rotor end, we put a head on there, a rotor head we call it, and then the rotor just plugs into that, so you could change the rotor and the stator without removing any piping. So
They could have even gone smaller on these pumps because
yeah,
you'll never run over 100 GPM to that machine ever.
really, yeah,
If you ever even get 100.
yeah.
So
Yeah, it's kind of funny. That's what happens. We see that a lot on these specs. You know, they oversize everything, then complain about price. You know.
yeah, I don't think that's too much.
Yeah, but that's typical. I mean, they're planning for future growth, and
Right.
nobody wants a pump that you just bought to be a bottleneck. So
Right.
yeah, that's again, this tag's pretty critical. You'll make sure it doesn't get painted over. You know, that tells you a lot about it. Can't think of anything else unless you guys have got questions.
Is that same information on the tag, it's on the manual too?
It is. Yes, it's the same manual. So if
I
you
would never count on that not getting painted over.
yeah, exactly. But if you had this number, if you record this number, you can always, call the factory and say, hey, I need the data sheets or the manual for this commission number. We'd send it to you. So,
Grease zerks, and I see one back here.
yeah, there's one down low here too for the motor bearings, and then this one here up for the
And that's
front
all
one.
in the manual
Yeah,
for how long.
it is. Yeah, and they put the grease specs in there as well.
And how much, I guess, too.
They do. Yeah.
Yeah.
Yeah, all our gearboxes have a O'Malley 220.
Yeah, that's pretty. Yeah, that's pretty standard.
Make sure that they added this sticker.
That's just some trees to show the outside to check it.
All right.
Is that a purge point on the bottom where you can purge the grease through the back?
Yeah, you can down here on the bottom. Yeah, you can. So these are standard WEG motors. So
Yeah, we have a lot of them.
yeah,
We have all those.
yeah, WEG. That's a good motor. I think these are the.
Them are heavy.
Yeah, these are the W22. So that's like
They're
a
heavy. They're
yeah,
built pretty good.
yeah,
They're built in Mexico.
yeah, yeah.
How many horsepower is that?
That's 10.
10?
Yep.
Yeah, because these flange bolts